Hai semua. Right, so we are going to wait until 4:03 or 4:04. 4 minit lah. Saya tunggu 2 minit sikit. Right, so today we are going to learn about geometric sequence and then I think one example on binomial expansion. Let's see if we can do more. We are going to do more. Oh, by the way, welcome back everyone. Selamat datang. Jadilah Madam RM2 loh. Kuliah ada masa tambah tak hari ni? Nope. Hari ni tak ada. Hari ni sampai pukul 5 lah macam biasa. Oh, by the way, tomorrow pukul 9 lah. 9 malam. Okay, let us start then. There are 28 of us. Okay, so sequences and series. So we are still in the first subtopic, sequences and series. So today we are going to proceed with geometric sequence and then some binomial expansion as well. Okay, so at the end of the lesson, you should be able to find the n term of geometric sequence and series. So this is a formula for how to find the term for geometric sequence, and this is the formula to calculate the sum of a geometric sequence. So Tn equal to AR n minus 1, and then Sn is equal to A1 minus R to the power of n over 1 minus R. And our common ratio or R shouldn't be equal to 1. Otherwise, we are dividing by a 0 and that will be undefined. Okay, and then the second one about binomial expansion. So find the expansion of a plus b to the power of n, where n is a positive integer. So today our focus is only when n is a positive integer. So tomorrow night it will be what happened if n is not a positive integer or when n is a fraction. Okay, so now the third one, right? The n factorial notation. So this is n factorial. The way we read them is n factorial. And this is NCR as binomial coefficient. So binomial coefficient number, normally we write them down as NR or NCR. Okay, so now geometric progression. So what is a geometric progression? So geometric progression is a sequence of numbers in which any term can be obtained from the previous term by multiplying a certain fixed number called the common ratio. So we are going to times them with some fixed number called the common ratio. So a geometric progression is also known as geometric sequence. So sometimes we call them GP, sometimes we call them geometric sequence. GP stand for geometric progression. So GP, geometric progression or geometric sequence. Okay, so a geometric sequence can be written as, so we got A, so AR square, AR cube, AR to the power of n minus 1. Okay, so where is the common ratio? So those are the R, the common ratio. where r cannot be equal to 0, or of course cannot be equal to 1 as well. So if we have 0, then that means other than the first term, everything else is 0. So that is why we cannot have 0 in our common ratio. And then that is the first term. So when we start, that is the first term. AR is the second term. AR square, that is the third term. AR cube, that is the fourth term. So that means AR to the power of n minus 1, that is actually the n term. Or sometimes you might write them down as Tn. So that is the n term. Okay, so the general term of a geometric sequence is given by, so Tn is equal to AR to the power of n minus 1. So what is A? A is the first term and R is the common ratio. So first term, common ratio. Okay, so this is our common ratio. So you can actually use the second term over the first term, or third term over the second term, or you can use Tn over Tn minus 1. So this is in general. R is equal to Tn over Tn minus 1. Okay, so now example 1. Given the geometric sequence 8, 16, 32, 64, and dot dot dot. So now the first one, we have to find the general term, and then B, we have to find the ninth term. Okay, so now what is the first term? So obviously this is your sequence. The first term is 8. And then how to calculate the common ratio? So we are going to do 16 over 8, or 32 over 16, or 64 over 32. So you can use either one. So for this one, I'm using the second term over the first term. So T2 over T1. So 16 over 8. So the common ratio will be 2. So now, if you substitute into the formula, the general term Tn is A, r to the power of n minus 1. So the first term is 8, the common ratio is 2. So we are going to get 2 times 8 times with 2 to the power of n minus 1. And then if you look at 8, 8 is actually 2 to the power of 3. So we can actually change something into a common base. So we have 2 cubed times with 2 to the power of n minus 1. So now using the rules of indices, we can actually simplify them. So it will be 2 to the power of n plus 2. So we are going to get 3 plus n minus 1. So that is how we get 2 to the power of n plus 2. So that is our general term. So now let us calculate the ninth term. So Tn is A r n minus 1. So A is 8, r is 2 to the power of 9 minus 1. So 8 times with 2 to the power of 8, the answer will be 2048. So that is the first example. Quite easy, right? Okay, so now second example. The n term of a sequence is Tn equal to 2 over 3 to the power of n minus 1. Show that this is a geometric progression. And then B, find the value of n, where Tn is 256 over 6561. Okay, so now we need to show that this is a geometric progression. So in general, we must calculate the r. R is Tn over Tn minus 1. So we are going to calculate the common ratio. Okay, so R, the common ratio, this is Tn over Tn minus 1. So Tn is 2 over 3 to the power of n minus 1. So that means if you have Tn minus 1, we place the n with n minus 1. So we are going to get n minus 1 minus 1. Simplify them. So you are going to get n minus 1 minus n minus 2. And then of course, n minus n cancel out. So we have negative 1, positive 2. So it will be 1. So the answer for this is simply 2 over 3. So since we have a constant as our common ratio, therefore this is a geometric progression. So do make sure your common ratio, you are going to get some constant. So what do I mean by constant is that it must be independent of any other variable. So there are no variable here. No more x, no more n, no more a. We only have some constant or some number. So that is why we can say that this is a geometric progression. Okay, so now let us go to B. Find the value of n where Tn is 256 over 6561. Okay, so Tn is 2 over 3 to the power of n minus 1. So you let them equal to 256 over 6561. And then as you can see over here, we have n as the power. So that means we can actually change this into something with the same base. So this is 2 over 3 to the power of 8 equal to 2 over 3 to the power of n minus 1. If you don't want to change it into a common base, you can actually apply log on both sides. So either one, either apply log on both sides or you can change everything into a common base. Sebab dia ada base yang sama, so kita boleh pakai base yang sama lah. Kalau rasa macam payah sikit ke, pening ke apa ke, then you can apply log on both sides of the equation. Okay, so I have a common base, so I can actually compare the index. So I got n minus 1 in 8. So n minus 1 must be equal to 8. So that means n must be equal to 9. So that is for second example, part B. Doing good so far? Okay, so now the sum of geometric sequence. A geometric sequence is AR square, AR cube up until AR n minus 1. Okay, so this is the formula for Sn, the sum of the first geometric sequence. So Sn, that means the n geometric sequence up until n. So A 1 minus r to the power of n over 1 minus r, or you can use another formula, ARn minus 1 over r minus 1. Actually, we can use either one of them. Mana-mana pun boleh lah nak guna either one. But you have to keep in mind that your common ratio shouldn't be equal to 1. Apa-apa pun tak boleh sama dengan 1. Otherwise, your denominator is equal to 0 and everything will be undefined. So you can choose either formula to use for Sn. Okay, so we got another one for geometric sequence. So we don't have them in arithmetic. So this is only for geometric sequence where we do have something called the sum to infinity. So S infinity is A over 1 minus R, but there is a catch over here. Your common ratio should be, the modulus of that should be less than 1. So that means the common ratio should be in between -1 up until 1 in order for us to use the formula for S infinity. Okay, so now example 3, find S5 or sum of the first 5 term of the geometric progression in which A is equal to 27 and R is equal to 2 over 3. Should I give you some time? Rasa macam bosan buat seorang-seorang. Saya bagi masa untuk awak buat pula lah. So I'll give you perhaps 1 minute for you to try them on your own. So 1 minute starting from now. Thirty seconds to go. Do you get the answer? Mana yang spam tu selalu ada seorang yang apa entah nama dia, yang inventor tu tak nampak pun, hilang lah hari ni. Thumbs up. Do you get the answer, everyone? Can you write down your answer so that we can see? Are you guys ready to move on or not? So, please write down your answer. $70.333. Tahu tu dia correct je. Jawapan dia tak ada, correct je. Sabar je lah. Oh, tulis dah jawapan. Okay. 71/3. Okay. So, I think everyone get the same answer. So, let us check then. Okay, so A is 27. R is 2/3. So, now N is equal to 5 because we want to find the first 5 term. So, substitute into the formula as N is A, 1 minus R to the power of N over 1 minus R. So substitute and then you use your calculator. So the answer is 211/3. So well done everyone. Tahniah semua orang. Okay, so let us go to the next example. Calculate the sum to infinity of the series 2 plus 1/2 plus 1/8 plus 1/32 plus ... Okay, so now what is the first term for this one? The first term, obviously, this is the first term. So 2 is the first term. A is equal to 2. So now let us calculate the common ratio. So common ratio, of course, you can take 1/2, you divide them by 2, or you can take 1/8, divide by half, or 1/32, divide by 1/8. Okay, so when we divide them, we should be able to get that the common ratio is 1/4. So we have the value of A, we have the value for the common ratio. That means we can replace this value A here, this value for the common ratio here. So we got 2/1 minus 1/4. So 2/3/4. So the answer for the sum to infinity is 8/3. Okay, so done with this. Next. Okay, so express each of this number as a quotient A/P. So you remember we have S infinity before this. What do we mean by S infinity is that it should be sum to infinity, right? So if we have 1.6 with a bar on top of the 6, it simply means that we are going to get 1.66666 ... So this is what we mean by sum to infinity. So dia ada ... kat belakang tu lah, sebab tu dia boleh jadi sum to infinity. Okay, so 1.6 with a bar. So I'll give you, I'll teach one example and then I'll let you guys do another one. Okay, so 1.6 with a bar. So that is actually 1.666 ... Okay, so 1 is actually 1. So now we simply take the number that are repeating because we are going to calculate S infinity for the number that are repeating. So 666 ... that is actually 0.6 plus 0.06 plus 0.006 plus 0.0006 and ... of course. Okay, so now we are going to calculate S infinity only for this term because over here we have plus ... So A is 0.6. The common ratio is 0.06 over 0.6, which is 1/10. So now we are going to substitute into S infinity. S infinity is A over 1 minus R. So A is 0.6. So this is A. And then this is R, 1/10. So we substitute 1.6 with a bar, that is actually 1 plus A 0.6 over 1 minus 1 over 10. Okay, so now simplify your right hand side, simplify this term. So you are going to get 6 over 10 over 9 over 10, and then simplify this fraction. You are going to get 5 over 3. So 1 plus 2 over 3. So it will become 5 over 3. Can you? So do remember to write them down first and then check which number they are repeating. So from that, we are going to calculate S infinity for that number. So for that number, do make sure to calculate what is the first term and what is the common ratio, and then substitute. Do make sure to simplify the fraction first before you add with 1. So that is how we come out with 5 over 3. Okay, so now we have B. So B is 5.459. So a bar on top of 59. So we are going to have 5.4595959 dot dot dot. So the thing that are repeating is this term over here. So I give you around 3 minutes for you to calculate what is the fraction for this one. 3 minit lama sikit lah saya bagi. And then please let me know what do you have as your answer for this one. So your 3 minutes starting from now. You must give your answer in fraction, okay? Don't give your answer in decimal fraction. Do make sure to read this very carefully and determine what is the first term and what is the common ratio. Be very careful when you find your first term and your common ratio. One minute to go. Ten seconds to go. 8, 7, 6, 5, 4, 3, 2, 1. Done. Do you have your answer? Or should I give you some more time? Nak tambah masa? Oh yo, dapat dah. 4919 over 900. Orang lain dapat jawapan yang sama ke? Okay, so let us check then. So 5.4 plus, so this is the term that goes on continuously. So 0.059, so do remember we have 4 over here. So it should be 0.059. And then the second 59 is over here. So 0.00059. The third 59 is over here. So 0.0000059. Okay, so now plus dot dot dot, of course. So we got to calculate S infinity for this term. So find out the first term. First term is definitely this one. So this over this, find out the common ratio. So common ratio is 1 over 100. So now substitute into the formula, A over 1 minus R. So we have 5.4, 0.059 over 1 minus 1 over 100. So simplify them a little bit. 0.059 is actually 59 over 1,000 over 1 minus 100. So it should be 1081 over 198. Tersalah ni kot masa simplify tu. I think masa simplify tersalah kot. Nampak ke kat mana tersalah? Amran, Daus dengan Nazmi, nampak ke? Do you know where yang tersalah tu? Jumpa. Saya rasa mostly masa dekat sini nak simplify. So be careful when you simplify them. Okay, never mind. If you cannot find where you make the mistake, do make sure to send it to me and I'll look at them. Nanti saya tengok lah. Okay, so now we want to proceed with another subtopic which is called the binomial expansion. So we have finished the first subtopic which is sequence and series. So now we are going to proceed with binomial expansion. Okay, so binomial expansion. So this is basically for a positive integer, 1, 2, 3, 4 and so on. So if we have a plus b to the power of n, a plus b to the power of 1, a plus b to the power of 1, that is simply a plus b square. So it will be a plus b times with a plus b, which is a square plus 2ab plus b square. And then if we have a plus b cubed, that will mean a plus b times with whatever we get before this for a plus b square, which means a cubed 3a square b, 3ab square plus b cubed. And this is for a plus b to the power of 4. So we got a plus b and then this is actually a plus b cubed. So now the question is, are we going to keep using this when we reach up until a plus b to the power of 10? So takkan kita nak expand satu per satu. Macam ni, satu sampai kuasa 10. So most likely we are definitely going to do some mistake somewhere and the coefficient will be wrong. So that is why we have to learn binomial expansion. Okay, so this is expansion of a plus b to the power of n only for positive integer. So we can actually use the Pascal triangle. Okay, so what is Pascal triangle? Okay, so there are n plus 1 terms. So that means if you have n, that means we are going to have n plus 1 term. So if you have a plus b square, that means we are going to get 3 terms. If you have a plus b to the power of 6, that means we are going to get 7 terms. So there are definitely n plus 1 terms. So we will begin with a to the power of n and n with b to the power of n. So when we start, the first one will be, let's say if you have a plus b square, so that means the first term will be a square plus dot dot dot, the last one will be b square. And then this one, the first one will be a to the power of 6 plus dot dot dot. The last one will be b to the power of 6. Okay, so that is what we mean by the first one. And then second one, the coefficient of the first two terms are 1 and n. The power of a decreased by 1. I think it will be easier if we can look at the Pascal triangle. Okay, let us go to the Pascal triangle. Okay, so this is Pascal triangle. Okay, so on the left hand side and the right hand side, this is always 1. So we always have 1 on the left hand side and right hand side. So 1, 1, 1, 1, 1, 1, 1. Okay, so this is actually for a plus b to the power of 0. So it will be equal to 1. Anything to the power of 0 is always 1. A plus b to the power of 1. So this number is actually the coefficient. So this is a plus with b. And then if you have a plus b square, so this number is the coefficient. So remember, before this we have a square, b square. So right in the middle we actually have 2ab. Okay, if we have a plus b cube, so based on here, I know that I will have a cube plus 3a square b plus 3ab square plus b cube. So 4 terms because this is cube. And this is for a plus b to the power of 4. Okay, so now how do we get the middle one? So this one actually comes when you adding these two numbers together. So 1 plus 1, so this is 2. And then 1 plus 2, so that is how you get 3. 2 plus 1, also 3. And then 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. 1 plus 4, 5. 4 plus 6, 10. And then 6 plus 4, 10. 4 plus 1, 5, and so on, of course. So this is only up until a plus b 5, a plus b to the power of 6. Of course, you can actually expand them until a plus b to the power of 10 or any power that you want. Okay, so for example, the fifth line of the Pascal triangle is 1, 5, 10, 10, 5, 1. So that means if you have a plus b to the power of 5, so this is 1. So the first digit, this is 1. A to the power of 5, b to the power of 0, 5, a to the power of 4, b to the power of 1, plus 10, a cube, b square, 10, a square, b cube, 5, a1, b4, 1, a0, b5. Okay, so what we can see is that the power of a is actually decreasing, but the power of b should be increasing. So those are the two things that we should keep in mind. The power of A will decrease, the power of B will increase. Okay, so now this is how we want to expand using the formula. Okay, so Pascal triangle is only helpful for finding the coefficient of terms in the expansion with small values of n. Of course, if you have n is 20, you are not going to do your Pascal triangle until end of the A4 paper. So that is why normally we are going to use the binomial coefficient formula. So for large values of n, we use the general formula for binomial coefficient involving the factorial notation. So normally we are going to use NCR, where NCR is actually n factorial over r factorial over n minus r factorial. So this one will be very useful when we want to calculate the proving question. So yang ni selalunya soalan proving lah nanti nak guna. Okay, so now a plus b to the power of n. So if you refer to the formula, we are going to start with NC0, NC1, NC2, NCR up until NCn. The power of a should be decreasing. So we start with n. And then we should deduct 1 to it, so n minus 1, deduct another 1, so n minus 2, and so on until you have a to the power of 0. So that is for the a. If you refer to the b, the power for the b should be increasing. So let us change the color a little bit. Okay, so this is b. So we start with b to the power of 0 and then we add 1 to that. So b to the power of 1, b square, br until b to the power of n. Okay, so that is the first term, nc0, anb0. So first term, second term. So that means this one over here is when you want to calculate the n term or the n term, the n. Okay, so example 6. By using binomial expansion, expand 1 minus 2x to the power of 4. Okay, so firstly, let us check what is a, what is b, and what is n. So we are going to use the formula for a plus b to the power of n, right? Okay, so let us check. So a is 1. So a is 1. What is b? So b is this number. Don't forget you have to take the sign as well. So b is negative 2x. Meanwhile, the power n, so n is actually equal to 4. So now let us expand them. Okay, so we have 1 minus 2x to the power of 4. Okay, so check first. We have 4 as the power, so that means I should have 5 terms. So let us get ready with 5 terms. So firstly, I will have first term, second term, third term, fourth term, and then fifth term. Okay, so now the first one we should replace with binomial coefficient. So the power is 4. So this is 4, always 4 on top. Okay, so now we should start with the lowest power or the lowest number, sorry. So the lowest number 4c0, 4c1, 4c2, 4c3, 4c4. So that is for the binomial coefficient. Okay, the second one, we have to write down the a. So a is 1, 1, 1, 1, and 1. So now let us write down the power. Okay, so the power for A, that one should be decreasing. So I will start with the highest power, which is 4, and then decrease to 3, 2, 1, 0. So that is for the power of A. And of course, now we should replace with B. So B. Okay, so B is negative 2x, negative 2x, negative 2x, negative 2x, and another negative 2x. So now let us write down the power. So the power for the b should always be increasing. So we will start with the lowest, which is 0, 1, 2, 3, and then 4. Okay, so now let us find out what is the value. Okay, so 4C0, 4C1, 4C2, 4C3, 4C4, we can actually use our calculator for that. So you have to find C. So kalau tengok calculator yang dekat simbol bahagi tu, tapi nanti kena tekan shift dulu. So 4 shift. Okay, so 4C0. So it should be equal to 1. So 1 plus 4C1. So it will be 4. Plus 4C2, 6 plus 4C3, 4. And then of course 4C4, which is 1. Okay, so this is simply for binomial coefficient, and then we're going to expand them one by one. 1 to the power of 4, so that is simply 1. Negative 2x to the power of 0, anything to the power of 0 is always 1. And then 1 to the power of 3 is always 1. Negative 2x to the power of 1, so that is simply negative 2x. 6, 1 square, so that is simply 1 again. Negative 2, if you square them, that will be 4. And then x square. 1 to the power of 1 is simply 1, of course. Negative 2, we cube them first, so it will be negative 8. And then, of course, x cubed. 1 to the power of 0 is simply 1. Negative 2 to the power of 4, that is simply 16. And of course, x to the power of 4. So now we can actually simplify everything. So 1, 1, 1. So that is simply 1 plus 4 times 1 times negative 2x. So that one will become negative 8x. So this is negative 8x. 6 times 4. So this is 24. X squared. And then 4 times with negative 8. So negative 32. X cubed. And then 1 times with 16. So this is 16. X to the power of 4. So do check how many terms. 1, 2, 3, 4, 5. So 5 terms for something to the power of 4. So that is okay. 4C4. 4C4 macam nak tekan dengan calculator. So 4. Use 4 first. And then shift divide 4. So it will become 4C4. So tekan 4 dulu. Lepas tu shift. Simbol bahagi. Lepas tu baru tekan 4. So 4C4. So that one will be equal to 1. Boleh? Boleh ke? Method? Okay. Right. Next. Okay, so definition of n factorial. If n is a positive integer, then n factorial is given by, so n factorial is n times with n minus 1 times with n minus 2 times with n minus 3 dot 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 up until 1. So stop sampai 1 lah, jangan sampai kosong lah. Nanti kan jadi kosong. So n factorial n, and then you minus 1, so n minus 1, n minus 2, n minus 3 dot 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 until 1. Okay, so for example, if let's say we have 5 factorial, so 5 is 5. 5 factorial is simply 5 times 4 times 3 times 2 times 1. Okay, so that is example 7. The definition of a binomial coefficient. So let n and r be whole numbers with n greater than or equal to r. Then NCR is simply n factorial over n minus r factorial over r factorial. So this is the formula that I asked you to remember before this. So do remember them. N factorial over n minus r factorial over r factorial. So this is r, this is n. So firstly, take this number, so n factorial, and then you minus them, so n minus r factorial, and then simply r factorial. Okay, so done with this, let's proceed with the next one. So now, example 8, evaluate 5C2. So we are going to use the formula for this. So what is 5C2? 5C2 is actually 5 factorial over 5 minus 2 factorial over 2 factorial. So if you want to simplify this, this is like 5 factorial over 3 factorial, 2 factorial. And then to simplify the 5 factorial, this is 5 times 4 times 3 times 2 times 1 over 3 factorial is 3 times 2 times 1 times with 2 factorial, so times with 2 times with 1. So 3, 2, 1, 3, 2, 1. 2, 4, 2. So you can actually simplify them. So that is how we come out with 10. So now I want you to do some proving question. So show that NC2 is actually equal to n times with n minus 1 over 2. So do make sure to start from the left hand side first, NC2, open using the formula, and then try to simplify them to get n times with n minus 1 over 2. So perhaps I'll give you 3 minutes for you to try them first. So saya bagi 3 minit awak try dulu. Try to start from the definition first. What is the definition of factorial? Or start with the definition of binomial coefficient first, and then simplify them using factorial. Okay, done. What about you guys? Done as well? Have you proof? Dapat proof ke? Okay, so let us try to use the definition for NC2. Okay, so NC2, so if you use the formula, it's supposed to be n factorial over n minus 2 factorial and then 2 factorial, right? So NC2, this is actually n factorial over n minus 2 factorial and 2 factorial. So n factorial, we can actually simplify them a little bit. So this is n minus 1, n minus 2 factorial. So the reason why I change it until n minus 2 factorial is because I want to divide them with the n minus 2 factorial. So this divide with this, simplify them. So we are going to get n minus 1 over 2 factorial, which is simply n minus 2 over 2. So I think that's it. I don't think I have any more question. Let me check first. Yep, I don't have any more questions. Okay, so that's it for lecture 2 out of 3 for sequences and series. So I'll see you guys tomorrow for the last lecture for chapter 3. So we are going to finish chapter 3 by this week. So I'll see you guys tomorrow. Thank you, class. Bye bye. Have a nice day, everyone.